Assalamu alaikum, student. So today we will deal with the topic aldehyde and ketones. Aldehyde and ketones are typical carbonyl compounds. Carbonyl means, carbon, carbon, carbon oxygen double bond, and two valences are free where other groups could be there. So this is called carbonyl compound. So the carbonyl compounds are the compounds containing this group. Type of the carbonyl compound, we can categorize these carbonyl compounds into two categories. The typical carbonyl compounds, which are generally known as carbonyl compounds, are aldehyde and ketones. And aldehyde has this group that on one side of the carbonyl compound is hydrogen. Yeah, or in other words, you can say that on uh, one of the valency in carbonyl group is saturated by hydrogen, and it is must. And other could be there. For example, in this molecule that is formaldehyde. So this is the formaldehyde, acetaldehyde, and IUPAC names are methanol, ethanol, propanol, butanol. So these are the IUPAC name of these compounds. And another type of the typical carbonyl compound is is ketone. So in ketones, you can see here the smallest ketone is acetone or the propanol. Why? Because in ketone, it is must that both the valences of carbonyl carbon is saturated with the other alkyl groups or other carbon atoms. So it can never be on the first position. So it is not, it never be on terminal position. So this ketone has 3 carbon atoms, this has 4 carbon atoms, this has 5 carbon atoms. So accordingly, we can name these. Suffix for aldehyde is as you have seen here, that methanol, ethanol, propanol, butanol, and you know it, we have studied it in IUPAC names. So in IUPAC naming, we have already covered these topics. And on is the suffix for ketone. So the name is propanon, butan-2-on or butanon, because whether it is here or here, in both the cases, only one 4 carbon containing ketone is possible. So you can write it butan-2-on or butanon simply. And pentantherion, but here it is must to write the position because it could be pentan-2-on. And although I have mentioned the hyphen in between them, but we should avoid this hyphen in correct naming. So see, I should avoid this propanon, and no need to mention the name here. So we can write here is butanon, but here the mentioning the position is important in pentanone because pentan-2-on is also possible. So that's why. But all of these things we have covered in IUPAC naming. Now the another type of carbonyl compounds are atypical carbonyl compounds, which are including carboxylic acid. Carboxylic acid, if you are writing the IUPAC name, then prefix oic acid is used. So you can see here, and it is always number 1 because only one valency is free if you draw the carboxylic acid. So rest of the valency of this carboxylic carbon atom of the carboxylic acid is fully saturated, except the one. Fully saturated means they are satisfied. Okay, although this bond is unsaturated. So here carbon chain can run only on one of the side. You can write it like this, or you may draw it like this. So whether right or left, it doesn't matter, but only one side it will run. So methanoic acid, 1 carbon atom, methanoic acid, ethanoic acid, propanoic acid, and butanoic acid. Okay. Now the derivative of carboxylic acids. If this OH is replaced by some other, these are called the derivatives of carboxylic acid. One of them is ester. In ester, what happens? This hydrogen is replaced by any alkyl group. For example, here it is ethyl group. Here it is also ethyl group, but here it is methyl group. So it depends that what groups are there. And as I have mentioned in other videos, that when we are writing the IUPAC name of the ester, this ethyl is ethyl has some gap between the main structure name, main name of the structure, because it shows that this ethyl is not bonded to the carbon to the basic chain of the organic compound. So here it is only one carbon atom, and here two carbon atoms are as a group on single bonded on this oxygen. So this is also called the alkoxy group. So ethyl methanoate. Similarly, it is also ethyl, so ethyl ethanoate, because there are two carbon atoms in the basic chain. And here one, two, three carbon atoms are in basic chain. So this is propanoic acid, but methyl group is there. So methyl propanoate or methyl propanoate. Okay. Amide. In amide, what happens? This OH is replaced by NH2 group. So the name of the amide ends on amide as suffix. So this is methanamide, ethanamide, propanamide. Acid halides has halogen group instead of this OH group. And the most common are chlorides, and sometimes bromides are also there. So this is methanoyl chloride. Oil chloride is the suffix, and there must be the gap between them. So methanoyl chloride, ethanoyl bromide, and propanoyl chloride. Acid anhydride is also another derivative of the carboxylic acid. So you can see here these acid anhydride, sorry. So in our syllabus, no complexity is given, alhamdulillah. So you just write one of them as a basic chain. So the name is acidic anhydride. These are the common names. Their IUPAC names are not required. So as these are not the part of our syllabus, so don't worry about it. So as it is acidic anhydride, this is the benzoic anhydride because benzene ring is associated there. The CCH5, you may write it like this. Sorry, this is not carbon, this is oxygen. And at both the end, benzene ring is there. So this is benzoic anhydride. So, but remember that when you are talking about general the carbonyl compound, then you will consider only the aldehyde and ketones, because these atypical carbonyl compounds are studied separately in our syllabus. Preparation of aldehyde and ketones. As both of them are carbonyl, so most of the methods for their preparation are same. But as they are not 100% same, so some of the reactions, some of the method of preparation are different, as they belong to different homologous series. So not necessary to have all the method of preparation same. These can be synthesized or prepared from different reactions, that ozonolysis of alkene that you have covered in alkenes, Ozonolysis of alkynes we have covered in alkynes, but we will we will study it again. Hydration of alkynes we have covered in alkynes as well. Cleavage or oxidation of 1,2-diols by periodic acid. Oxidation by alcohol by PCC. PCC is the pyridinium chlorochromate. Friedel-Crafts acylation that you have studied in benzene. Now see, one by one. Ozonolysis of alkenes. Alkene has a carbon-carbon double bond, and it can be oxidized by ozone. So this is one of the oxidation reaction, but it occurs in two steps. First, the ozone is added to this double bond and form this structure that is called ozonoid. So this ozonoid is formed. Later on, when this ozonoid is treated with zinc in water at 100 degrees Celsius, then it is converted into two carbonyl compounds. It depends which type of carbonyl compound is produced. It depends on the carbon atoms, where it depends on the alkene on either side of the double bond. And along with this, zinc oxide as a byproduct, side product is obtained. You can see here, this is the unsubstituted alkene. Unsubstituted alkene is ethene, because on both of the carbon atom, there is no other alkyl group. So this is called unsubstituted alkene. And the product is 2 moles of ethanol, because both of the carbon atoms are same. Both of them have two hydrogen atoms. So when bond is broken from here, the two oxygen atoms incorporated in each of the carbon atom, one oxygen is bonded as the double bond. So you can easily predict the product of the compound. Whatever the alkene is there, you just break the molecule at the double bond, and on both of the carbon atom, you just put a double bond with oxygen. So you will get two products. Let's see. Here, this is cis-butene. Cis because both of the methyl group are on the same side. Even if it was not cis-butene, even it was if it was trans-butene, the same product will be obtained, because the cleavage occurs on this position. So you can predict the product. That product must have the carbon oxygen double bond at this position. So it will also produce the same compound, because it is also the symmetrical alkene. This can be divided into two halves. So if it can be cut into two halves, it means this is symmetrical alkene. So symmetrical alkenes always produce the 2 moles of the respective aldehyde or ketone. So just like this, ozonide is formed and 2 moles of ethanol are produced. The solvent used for this reaction is dichloromethane. Condition for this reaction is actually minus 78 degrees Celsius for ozonide formation. Following the treatment with solution mixture by zinc or water, or zinc and dimethyl sulfide. But in our syllabus, this is not mentioned, so you can ignore it. So actually, I don't know why our book has written this 100 degrees Celsius, but as it was written in the book, so I have incorporated in my lecture. But actually, these are the conditions required for such reaction, where no heating is required in either reagent. So this 100 degree is not true. Now the question is there, whether in the examination, what should we write? So if you will write 100 degrees Celsius, then we teachers know about it. So don't worry. whether you write 100 degrees Celsius or you do not write, both will be accepted and you will lose no mark. You will get the full marks if your reaction is correct. And these two reagents, and here one of the reagent is given. So actually it all depends on what is the rest of the reaction. If rest of the reaction is correct, so the mistake that is in our textbook is ignored. Now the ozonolysis of alkene is continued. So as I told you that whether it is cis-butene or trans-butene, they give the same product. See, again, the 2 moles of ethanol are obtained. Both of them are vicinal disubstituted alkene. Vicinal disubstituted alkene means on adjacent carbon, same group is there. But here, there are the different groups on each of the olefinic carbon. Olefinic carbon means this sp2 carbon that is forming the double bond with other carbon atom. So this is 2-methyl-butene. Its IUPAC name. This is the basic chain. So its name is 2-methyl-butene. When it reacts with ozone, this ozonoid is formed. And after treatment with zinc and water, it produces one of the ketone and one is the aldehyde. So ethanol, mixture of ethanol and propanol is obtained. In common word, ethanol is called acetaldehyde and propanol is called acetone. So one of them is aldehyde, other is ketone. Now, if both of them, again, it is symmetrical, but both of them has no hydrogen. Both the olefinic carbon has no hydrogen. So that's why when it is broken here, this carbonyl carbon would have alkyl group on both the sides. So the product would be ketone, and this 2,2-dimethyl-butene gives first the ozonoid. Then in the second step, it gives 2 moles of propanol. Now see the next one. This is the ozonolysis of alkyne. When alkyne is treated with ethyne, when any alkyne is treated with ozone, a different type of ozonoid is formed where carbon-carbon single bond remains there. And in the next step, zinc and water reacts together to produce, as this carbon is same, so there is no cleavage of carbon-carbon bond, and we produce this glyoxal is the common name, or if you write its IUPAC name, it would be 1 to 2 carbon, eth, and because carbon-carbon bond is single, and both of them are aldehyde. So we should write it diol. And no need to mention the name because aldehyde are on the terminal. So one is on one terminal and another is on the other terminal. But remember that we will keep E of the N because now the next letter is not vowel. It is consonant. So the name is ethanediol and we keep this E. We don't omit this E. Okay. Now see the next method of preparation is the hydration of alkyne that we have covered previously in our hydrocarbon chapter named hydrocarbon. So this type of reaction is acid catalyzed electrophilic addition reaction because in electrophilic mechanism, water is added to the alkyne, that pi bond, and condition that is required is the presence of catalyst, and catalyst is the mixture of sulfuric acid and mercuric sulfate or mercury 2 sulfate. Temperature required is about 75 degrees Celsius, and typically it should be between 60 to 80 degrees Celsius. And followed by rearrangement, that is called tautomerization. Tautomerization, although this name is not the part of our syllabus, but I will explain it. because this is very important reaction, and especially for pre-medical students, because when they study the glycolytic cycle, their tautomerism occurs at the stage of enol pyruvate to pyruvate, conversion of enol pyruvate to pyruvate. So now see alkyne, one of the alkyne that is commonly ethyne is there. When water is added, both the carbon atoms are similar, both have the same one hydrogen atom. So no Markovnikov's rule is applied. One is getting hydrogen, other is having OH group, but double bond is still there. And it's called ethanol because this is ethene, and all is because of the OH group. And the common name of this is vinyl chloride. In general, such compounds are called enols, and the common name is vinyl chloride. Vinyl chloride. And after rearrangement, what happens? Actually, this hydrogen goes to this carbon atom, and this double bond moves here. So as a result of this rearrangement, this product is formed, and the name of this product, you can understand that this is ethanol. You can write it like this: CH3 CHO or CH3 C double bond O. In any way you can write it. But remember that both the carbon atoms are same. They have same number of hydrogen atoms. So only one product is obtained and no Markovnikov's rule is applied. But here, both the carbon atoms are not same. So OH must be added to this carbon atom. See, propine, reaction with water. So OH must be here. It follows the Markovnikov's rule. So the major product is propene to all. Here, position of all must be mentioned. Although the position of ene is not required, because when all is on the second position, OH is on the second position, so it is equivalent that whether you write from right or left. So the position of the double bond would be considered as one when OH is on the second carbon atom. But if it was any other case, then we must mention the position of ene as well. So after the rearrangement, definitely the second carbon becomes the carbonyl carbon. So definitely it should not be aldehyde. It is a ketone. So propanone is obtained. So in simplified version, you can write it like this: CH3 C double bond O. Okay. So here Markovnikov's rule is applied when both the acetylenic carbon atoms are different in terms of hydrogen. Now see the next reaction. And okay, I have mentioned one more thing, that addition of water to alkyne follows Markovnikov rule. So other than ethyne, all the alkynes give a ketone by this reaction after rearrangement, because there's no chance to have OH group on the terminal except the ethyne. Now the cleavage or oxidation of 1,2-diol by periodic acid. Periodic acid HiO4. Some students were pronunciate it as periodic because they have the same spelling, periodic and periodic. So if you know the correct structure or name of the compound, then you can understand that this is periodic. Okay, so sometime the student may confuse. The substrate molecule is alcohol that has two OH group on vicinal, any adjacent carbon atoms. So 1,2-diol, you can say 1,2-diol. 1,2-diol doesn't mean that according to the terminal of the compound, one OH is on one carbon and another is on second carbon. Now, 1,2-diol means when both of the OH are on the adjacent carbon atom, it is also called 1,2-diol. This is called oxidative cleavage because oxidation is occurring and bond cleavage is also occurring, just like the ozonolysis of ethane. Ozonolysis of ethene. Product depends on the number of alkyl groups attached to the carbon atom bearing OH group. Just like the ozonolysis of alkene, it has different products. See, if no alkyl group, then the product is methanol, means ethene is converted into 2 moles of methanol. If one alkyl group is there, then one is an aldehyde, any other aldehyde, and other one is methanol, or any other aldehyde. It could be any aldehyde. It depends on the position of the double bond in the alkene. If two alkyl groups are there, then the product is ketone. Now see, in this molecule, there is no hydrogen atom. Oh, sorry. There is no alkyl group. All of these are hydrogen atoms. So what happens when pyridic acid reacts? It produces 2 moles of ethanol. So what happens actually? Molecule is cleaved at this position, and both of them are converted into aldehyde having hydrogen on either side of the carbonyl carbon. So 2 moles of methanol is produced, as we have mentioned in the first point. But if there is, and this iodic acid, pyridic acid is converted into iodic acid. If you remember and you calculate the oxidation number of iodine here, then you will find it is +5. No, it is +7, not +5. It is +7. And here, iodine has +5 oxidation state. So it means definitely it has gained electrons, so it is reduced. Iodine in periodate is reduced to iodic acid, while the carbon is oxidized into carbonyl compound. So alcohol, the one of the oxidation state of alcohol is aldehyde or ketone, means carbonyl compound, and the next step of oxidation produces carboxylic acid, and the completely oxidized form of carbon is carbon dioxide. Now see here, one of the carbon is having one alkyl group, but other has 2 alkyl groups. This could be any two, could be methyl or any other alkyl group. But remember that now when these are broken, so this is converted into carbonyl. So this carbonyl would be ketone, and this carbonyl would be aldehyde that you can see here. So one is ethanol and one is propanol. And along with this, we obtain the iodic acid. So one of them is aldehyde, another one is ketone. So see the second and third point. If one alkyl group, then product is an aldehyde. If two alkyl groups, see on left hand side there is only one alkyl group, so this part is converted into aldehyde, and the other side which has 2 alkyl groups, it is converted into ketone. Now see, oxidation of alcohol, although it was also oxidation, but that was the oxidative cleavage where carbon chain length decreases. Carbon is cleaved at carbon-carbon bond is cleaved where alcohol groups were attached. Now the substrate is primary and secondary alcohol. Remember that tertiary alcohols cannot be oxidized by some of the reagents. Type of reaction is oxidation. The reagent is PCC, pyridinium chlorochromate. So PCC, P is taken from pyridium, C, one of the C from chloro, and another is from chromate. Product depends on the type of alcohol. If this is primary alcohol, then aldehyde is produced. If secondary alcohol, then ketone is produced. Tertiary alcohols cannot be oxidized by PCC, as I have already mentioned it. See, this is the primary alcohol, ethanol. So ethanol is oxidized to produce ethanol, and this reaction stops here. It does not go further oxidation reaction. So this is the good method for obtaining carbonyl compound, aldehyde or ketones. So when this is secondary alcohol, for example, 2-propan-2-ol, so this propan-2-ol undergoes the same type of reaction, but it produces propanol. So primary alcohols give aldehyde, secondary alcohol gives ketone, and tertiary alcohols cannot be oxidized by PCC. Now, preparation of aldehyde and ketones by Friedel-Crafts acylation reaction that we have already seen in aromatic compounds in chapter of hydrocarbon. They produce ketones on aromatic ring. This is specifically for aromatic ring. In our syllabus, only one aromatic compound is there, that is benzene. So we will see it with benzene. So the substrate is one of the aromatic compound. It is electrophilic substitution reaction on aromatic ring, and here that aromatic ring is benzene. Reagent is acyl halide, which are also called acetyl chloride, for particularly for ethanoyl chloride. Catalyst, aluminum chloride is used as a catalyst if the halide group is chloride. If halide group is bromo, then we will use aluminum bromide. Product depends on the type of the acyl halide. Whatever the acyl halide is there, it produces its respective aromatic ketone. Aliphatic acyl halide yield aryl alkyl ketones because on one of the side there must be benzene or any other aromatic compound. But if you are using acyl halide from the aliphatic chain, so a ketone is formed where on one of the side of the carbonyl carbon is aldehyde, is aromatic ring, and on the other side there is a alkyl group. So this is called alkyl aryl ketone. But if you are using aromatic acyl halide, then the product would be diaryl ketone, means on the body side aryl group is there. See here in this reaction, this group is transferred to the benzene ring. It is substituted here by electrophilic mechanism that we have studied when we studied the benzene and its reactions. So if you see here, this is the carbonyl. On one side there is aliphatic group, and on the other side aromatic group. So as I have written here, that aliphatic acyl halides yield aryl alkyl ketone. So this is the alkyl group, this is the aryl group, and aromatic group. So this is an alkyl aryl ketone. The common name of this compound is acetophenone. And remember that some of the common names are accepted by IUPAC, and acetophenone is one of them. Or otherwise, what you will write its name? You will write its name as 1-phenyl ethanone. because basic chain is considered the carbon atom having carbonyl compound. So this part is considered as the basic chain. But remember that these names are not the part of our syllabus. Now see, one is the benzene and another is the benzoyl chloride. So the acyl halide that we are using here, it is also an aromatic group. So if you see, one of the benzene is there. Suppose okay, suppose this benzene ring is this one and this acyl group is this. So what happened? Okay, so one of the benzene already is here in benzoyl chloride, in the form benzoyl chloride. So suppose this part is from benzoyl chloride and this is from benzene. So what happens? On both the side, aryl group is there. So this is the second type of ketone, that is aromatic acyl halide is used. So it yields the diaryl ketone. So that's all for today. Inshallah, we will come with the next video very soon.